In this example, we're going to look at how to find the volume of a torus. A torus is obtained by revolving a circle that does not meet the x-axis through 2 pi about the x-axis. The result of this operation is a donut, we could say, a tube that has the form of a ring. This solid is called a torus. Let us now look at such a torus, assuming that its cross-section has a radius of 1 centimeter and the distance from the center to the central line of the tube is 4 centimeters. We obtain such a torus exactly by revolving a circle whose center is 4 away from the x-axis and whose radius is 1 through 2 pi about the x-axis. The area that we're revolving can be described as the area enclosed between the upper semicircle and the lower semicircle. Let us name the upper semicircle F and the lower semicircle G. Let us first find the equation of the circle, and for that let us draw the right-angled triangle here. The lengths of the two lines here, this one is just x minus 0, and the length of this blue line is y minus 4. So we get for the equation of the circle that x minus 0 squared plus y minus 4 squared is r squared. Now using that r is 1 and applying minus x squared then and taking the root, we get y minus 4 is plus minus the root of 1 minus x squared. As a last step, we add 4, we get y equals 4 plus minus the square root of 1 minus x squared. And this leads directly to the function equations corresponding to the upper semicircle and the lower semicircle f and g, namely y equals 4 plus square root of 1 minus x squared and y equals 4 minus square root of 1 minus x squared. And the volume of the torus is now the integral from minus 1 to 1 of f squared of x minus g squared of x dx, and the whole thing times pi. We can rewrite that as integral of 0 to 1 only, using here 2 pi, so doubling the volume since we're then integrating only this part, which is just half of integrating the whole part. And f squared is now 4 plus square root of 1 minus x squared, the whole thing squared, minus the same thing now just with 4 minus 1 minus x squared, the whole thing squared dx. And when we expand the two brackets, the 4 squared becomes 16 in the second part also, so they cancel out since there's a minus in between. The same happens with the square root of 1 minus x squared. It becomes 1 minus x squared here, but it becomes also 1 minus x squared here, plus, because of the minus, it's this minus the other, so it cancels out. So what remains in the end is just the central part, which is 2 times 4 times the square root of 1 minus x squared. Here we get the same thing but minus. Because of the minus here, it becomes plus. So we have 2 times 4 times this, and we have it double, so 4 times 4. So we get in the end 16 times the square root of 1 minus x squared dx, ending up with 32 pi times the integral from 0 to 1 of square root of 1 minus x squared dx. So the next step is how to find the integral of 1 minus x squared under the root. To find that, we have to use proactive substitution, as I call it, and this means we set now x equal to a function of u. In this case, we say x is sine of u. Typically, what we did when doing substitution, we would say u is a function of x. We can do it also the opposite way around, so we set x equal to sine of u. We look at the derivative of this function. So we take the derivative of sine of u with respect to u, and we get dx by du is cosine of u. Now multiplying by du here, we get dx is cosine u du, and we substitute now everything in our original question here, integral of square root of 1 minus x squared dx. Substituting the x here by sine of u, we get square root of 1 minus sine u squared, and substituting now dx here by cosine u du, we get this here. So, reminding you, sine squared of x plus cosine squared of x is 1. So I get cosine squared of x is 1 minus sine squared of x. And since I'm taking here the root, I'll get cosine of u. I have to find the integral of cosine squared of u du. Previously, we have seen that the integral of this cosine squared of u du is this function here, 1/2 sine u cosine u plus 1/2 u. Since x is sine of u, to substitute it back, u is then arcsine of x, and cosine of u, which we will need here as well, we need u, sine u, and cosine of u. So cosine of u is, again using this unity here, cosine of u is the square root of 1 minus sine squared of u, and since the sine of u here is just x, so we get square root of 1 minus x squared. So we found square root of 1 minus x squared dx up here is integral of cosine squared u du, which is 1/2 sine of u cosine u plus 1/2 u, that's this here. And this is 1/2 times, now inserting for sine of u x, for cosine of u square root of 1 minus x squared, and for the u, what we found here, the arcsine of x. And so we find that the volume that we're looking for, which is this 32 pi times integral from 0 to 1 of square root of 1 minus x squared dx, as we see up here, that's this one here. So this is now using what we found, 1/2 times x times square root of 1 minus x squared plus 1/2 arcsine of x from 0 to 1. And sorry, the 32 pi is missing here. Now inserting that, we get 32 pi times, inserting 1, I get 1/2 times 1 times the square root of 1 minus 1, so times 0, plus 1/2 times arcsine of 1 minus, when I insert 0 over here, I get 1/2 times 0 times 1 plus 1/2 times arcsine of 0, and the arcsine of 0 is 0. Arcsine of 1 is pi half. So I get now 32 pi times, since all the rest becomes 0, times 1/2 times pi half, so 8 pi to the power of 2, which is approximately 79 units to the power of 3. Here in the end, you can have a look at how to find the integral of cosine squared x dx. So integral of cosine squared x dx, we take it apart as a product, and then using integration by parts, we say this is u dash, this is v. So we need u times v. Well, integrating this, we get sine of x, the v stays, then integral of u v dash, still the sine of x here, taking the derivative of cosine of x, we get minus sine of x. Multiplying now this times this, we get minus sine squared of x. The minus cancels out with the minus here, so that's the reason why we get this line here. We then replace again sine squared of x by 1 minus cosine squared of x. Use sine squared of x plus cosine squared of x is 1. Taking this integral apart, we get integral of 1 is just x, and then minus the integral of cosine squared of x dx. Now we have an equation, this equals to the whole thing here. Adding now on both sides integral of cosine squared of dx, it cancels out here, and here we get 2 of them. So we have 2 times the integral equals this part here. and hence dividing by 2 we get integral of cosine squared x dx is 1/2 sine x times cosine x plus 1/2 x plus c.